Audio. Okay, let's check. Okay, I should bring my audio in here. Good, it's much clearer than before. OK， 那么我尽量做得高一点，然后这样的话就可以看脑子。我还是喜欢这个。OK， 如果看不到我的这个，OK， 如果看不到我的头的话，也没有问题。OK， 没有什么问题。Good。好，那么OK, so I think I would try to talk in English. I don't know whether people would watch this, and I hope that they will, because it's all about science and research, which is really interesting stuff. Okay, good. Okay, so right now I'm going to read the latest papers, and then I will copy them to my Zotero, and we can chat together. And for some papers, I will talk about why I find them interesting, and how, and what kind of thoughts that we can draw from them. It'll be really interesting. Because it flows for electric. Okay, I think this would be really nice. Okay, I think this is nice. It's about hydrogen evolution, which is a really important reaction. And also, it has something with the heterostructure with interfacial defect engineering. And also, I'm going to use another room. Okay, another room research. So one roaming here, and I will do the daily literature. And we'll do something like this. Okay. Okay, so now let's moving on. Disentangling electronic and geometric effects in electrocatalysis through substitution isostructure into atomic compounds. Okay, this is really interesting because it is talking about something that, so in electrocatalysis, the electronic and geometric effects are often entangled together. For example, if you change the structure of your active site, then the electronic structure of the atom in there should also change. So it's really hard to separate them. And I think in this paper, they figure out a way, or they use that in this very specific examples. So okay, disentangling. Good, let's moving on. Kinetic rationalization of linear effects of asymmetric catalytic state reactions. I think this is about chemical kinetics. This is about kinetics. Okay, what is Curtin-Hammett conditions? Can we find something about it? Now, setting up water on porous nitrogen-containing layered carbon materials. The performance of computational model chemistries. Okay, I closed my Twitch, but I'm not sure whether... Okay, good. I'm still in here. I'll move down to another one. How coherence is governing diffusion heat transfer in amorphous solids. Okay, so this paper is about amorphous materials, which I think is really important, and also it's about diffusion and heat transfer, which is a really important transport phenomena, and coherence. Coherence usually means electrons. Let's see whether electrons. No. Okay. So what are they talking about? Wave packet simulations. I think it's about electronic the properties of electrons. Investigate thermal transport in amorphous silicon, in which thermal vibrations are simultaneously interpreted as the composition of particle-like and wave-like components. Okay, so it's like particle-wave duality. Particle-wave duality. Effects of local compositional and structural disorder of vacancy formation. I think this paper is very interesting because it's about local compositional and structural disorder. So the orderness and disorderness of the material is really interesting, like electrocatalysts, because if your system is very like disordered, then it's really hard to model that. because for ordered bulk or the ordered surface, you can use really small unit cell to represent the whole supercell. But for disordered system, you can only use a really large supercell. But that is that you assume that it has long range periodicity or long range oddness. But what about the true disorder? And also, disorder is correlating with the entropy of the system, and entropy is closely related to the free energy. And free energy is where that determines whether a material is stable or not. So I think those factors combined together is a really interesting combination. Density functional theory perspective on the non-linear response of correlated electrons across temperature regimes. Wow, today we really have many interesting papers. Okay, maybe I should chat. How do I get the link? How do I get the link of this? Share, okay. Twitter. Share to Twitter. Chemistry Research Live. Check it out. Questions about research. Or wrong research. Wrong code. Okay, it's my Twitch stream, and I would think that okay, share, copy URL. I don't know whether anyone would looking at here, but yeah. If I open this, can I really see what I'm browsing? If that is the case, it's really interesting. Okay, yeah, let's moving on. Oh, there's another one. Hello, welcome to my stream. Okay, let's moving on. No, not that interesting. Okay, neural interfaces based on quantum dots. Now investigating a fluorine-free based ionic liquid electrolyte with lithium metal. Okay, this should be interesting because it's correlated with the lithium-ion batteries. With the lithium-ion batteries, lithium-ion battery is a really interesting topic. Oh, okay. The person is gone. Okay, so here's my Twitch. I don't know why in the beginning it seems fine, but right now it's super slow. I don't know why that happens. Near room temperature synthesis. Okay, what if I put my microphone here? I must still be able to hear what I'm saying. I don't know. Let's check out. Okay, if I say something like this, can I still hear it? Okay. I think this volume is higher, right? This has higher volume. Okay, so let's do this. Highly efficient oxygen activated self-cleaning membranes prepared by grafting a metal organic framework. Titanium of copper. CO adsorption. Okay, this is fine. But what is this? DSM. DSM. Sorry. DSM zeolite, Sconomumba, high silica zeolite, molecular state. Okay. Pore size dictates anisotropic thermal conductivity. Thermal conductivity. Understanding the interaction between transition metal doping and ligand to promote CO2 reduction reaction. So this paper is about CO2 reduction reaction, which is really important and really popular electrocatalytic reactions that has been studied during the past 10 years, I believe. And also it's about metal doping and ligand atoms of zinc sulfide and zinc oxide. I mean, is this the density functional theory? I believe this is. Yeah, in this work we theoretically, okay, so it's a theoretical work. Highly accurate hydrogen fluoride dimer ab initial potential energy surface. Huh. Okay, there are 3 people. That's nice. Hello everyone. Welcome to my stream. Yes. So if you are interested in like room research or research related stuff, so we can discuss together. Oh my god, my internet speed is really bad. I don't know why. Could it because I'm doing Twitch? I'm doing Twitch live? I don't know. Or because this paper is really huge. Multi-center decomposition, molecular densities. Okay.我感觉是不是刚刚因为我打开了另外一个页面，所以说它在变得慢。然后如果我把这个Twitch先退一下的话，然后再进来，是不是会稍微的好一些？